Hello student, welcome to this chapter of chemical reactions and equations. This is a chapter in the subject of science for the students of 11th or 10th, even for state syllabus or CBSE or for ICSE. So it is useful for all the 10th standard students of the state syllabus or the central syllabus. So here this chapter is presented in the form of question and answers so that the students can write an accurate answer in the examination. So it is not in the form of notes, it is in the form of question and answers. Okay. So the first question of this chapter is that what is a chemical reaction? Give an example. So this is the first question. The answer is that it is a process in which one or more substances react to form some other new substances with entirely different properties. So this is the definition of the chemical reaction. Here we have given an example. You see, two substances are there. So this is the first substance. This is the second substance. So they undergo reaction. So the first substance is the CaO. It is a calcium oxide, or the popular name of this calcium oxide is the quicklime. And in the bracket we have written S. S means this shows that it is in the solid form. And the second substance is the H2O. As you know, it is a water. It is in the liquid form. And these two substances react together to form the new substance, CaOH twice. So this is the new substance formed. So it is actually calcium hydroxide, and its general name is slaked lime. So it is an aqueous solution. So this is an example for a chemical reaction where the two substances react together to form the new substances, and the properties of this new substance. For example, this slaked lime, it is having different properties as compared to this quicklime. So this is the first question. Next, we'll see what is the second question. What is a chemical equation? Second question is, what is a chemical equation? A chemical equation is the symbolic representation of a chemical reaction, and the reactants and products are represented by their respective symbols. So for example, here is there, this is a reaction, and this reaction is shown in this way. It is a chemical equation. It is a chemical equation, and these are called as the reactants. So this one, for this quicklime and water are referred as the reactants, and this slaked lime is a product. So these two reactants react together to form the product. So this reaction is represented symbolically in this way. So this symbolic representation of a chemical reaction is a chemical equation. So this is a chemical equation. Next question is, what is a word equation? Give an example. What is a word equation? When the reactants and products in a chemical equation are written by their names instead of their symbols or formula, it is called a word equation. So here is the example. Here I have given one example. You can see here magnesium is a reactant plus oxygen is another reactant. So these are the reactants. And when these two reacts to form the magnesium oxide, so it is a product. So these are the reactants, it is a product. And what is the difference between this equation and this equation? You can see in this equation, what is that? The reactants are represented by their chemical formula, but here the reactants and products are not represented by their chemical formula. They are written using their name. So here magnesium is there. Instead of magnesium, we would have been written Mg. For oxygen O, like that, we would have been used the symbols. But instead of using the symbols, their names are directly used to represent the equation. So when you are representing an equation in this form, it's called as the word equation of the chemical equation. Next, what is a balanced chemical equation? What is a balanced chemical equation? So this is a very, very important point in this chapter. A chemical equation is said to be balanced when the number of atoms of each element on the reactant side is equal to the number of atoms of corresponding elements on the product side. So to understand this, this sentence or the definition of the balanced chemical equation, you look at this equation. It is a chemical equation. So it is a chemical equation. Here zinc is there as one of the reactant plus sulfuric acid. H2SO4 is the sulfuric acid, is another reactant. And these together form a product called zinc sulfate, ZnSO4, zinc sulfate plus hydrogen gas is also released. So this is an example for a balanced equation because the number of atoms of the different elements on reactant side should be equal to the number of atoms of the product. The number of atoms of the different elements in the product should also be same. For example, you see on reactant side, zinc is having one atom. On product side, zinc is one atom. So it is equal. And hydrogen, here two atoms are there. And here also two hydrogen atoms are there. So they are also equal. And here, yes, one sulfur atom is there. Here also one sulfur is there. They are also equal. And oxygen, here four atoms are there. And here also four atoms are there. So they are also equal. So hence, every element having the same number of atoms in the reactant side as well as the product side, and hence it is an example for a balanced equation, a balanced chemical equation. So a chemical equation is said to be balanced when the number of atoms of each element on the reactant side is equal to the number of atoms of corresponding elements on the product side. So now, as I have checked right now, so this is an example for a balanced chemical equation. So I'll move to the next question. Give the classification of chemical reactions. Give the classification of chemical reactions. So based upon the chemical changes that take place in a chemical reaction, following reactions are possible. So when the two reactants react each other, what are the changes takes place on the reactant side and what kind of product is formed? So these are the factors depending on which the chemical reactions are classified in this way. So there are totally 5 different types of chemical reactions are there. One is called as the combination reaction. Second one is the decomposition reaction. And third one is the displacement reaction. And fourth one is the oxidation and reduction reaction. And fifth one is the exothermic and endothermic reactions. So these are the different types of reactions generally which takes place depending upon the different kinds of reactants involved in a chemical reaction. So next we'll see one by one. So next question is what is a combination reaction? Give an example. So now we'll see what is this combination type of reaction. A chemical reaction in which two or more reactants combine to form a single product is called a combination reaction. So it is a chemical reaction, and here two or more reactants combine together to form a single product. Now come to this example. This is an example. So here one reactant is there. It is a calcium oxide, also known as the quicklime. It is in the solid form because S is written. Plus water, H2O water is there. It is generally liquid. And these two reactants form a single product. You see, this is a single product. So calcium hydroxide is formed, which is also known as the slaked lime, and plus it leads to this equation leads to generation of some heat energy in this way. So this is an example for the combination reaction because two reactants are there. They combine together to form a single product. So in this reaction, calcium oxide, this one CaO, reacts vigorously, means very strongly with water to produce a slaked lime, which is the calcium hydroxide, releasing a large amount of heat. So here the amount of heat energy is also very, very large. So it is an example for the combination reaction. Next, we'll move to what is decomposition reaction. Explain its types with example for each. So first we will understand what is the meaning of decomposition reaction. A reaction in which a single reactant breaks down to form two or more products is known as a decomposition reaction. This reaction is opposite to that of the combination reaction because in combination reaction, two reactants combine together to form one product, but here one reactant is there that breaks down to form the two or more products. So hence these two reactions are opposite to each other in nature. So on the basis of the form of energy required for the reaction, three types of decomposition reactions are possible. So here the subclassification of this decomposition reaction is there. So the first type of the decomposition reaction is the thermal decomposition. So when the energy in the form of heat is given to a reactant for its decomposition, then it's called the thermal decomposition. So thermal is generally what is that leads to the meaning of heat energy, and hence here the energy supplied to decompose a substance is the thermal energy or the heat energy, and hence it is called as the thermal decomposition. Here is the example. So calcium carbonate is there, which is in the solid form. When it is heated by giving the heat energy or the thermal energy, This calcium carbonate breaks down into calcium oxide plus carbon dioxide is also formed. So this calcium oxide is a solid form, but this carbon dioxide gas is formed, released. So it's a thermal decomposition process. Next one is the electrolytic decomposition. Next one is the electrolytic decomposition. When the electrical feed energy is used for the decomposition of a reactant, then it's called electrical decomposition or electrolysis. So electro means electric field, lysis means breakdown. These are the Greek words. Lysis means breakdown. So when the electrical field energy is supplied or utilized to break down a reactant into its components, then it is called as the electrolytic decomposition, electrolysis decomposition. Here is the example. So NaCl, sodium chloride, which is in the liquid form, is there. When we pass the electric current through this sodium chloride, sodium and chlorine atoms are separated. So a breakup or the decomposition of the sodium chloride takes place in this way. So sodium and chlorine are separately formed. So this is the electrolysis decomposition. Next type of decomposition process is the photolysis or photochemical decomposition. Photo means a light, lysis means a breakdown. So that is why here the type of energy utilized for the decomposition of a reactant is the light energy, and hence it is called as the photolysis. So when the energy in the form of light is used for the decomposition of a reactant, then it is called the photolysis or photochemical decomposition. So here is the example. AgCl, so this it is a silver chloride. It is very much sensitive to the sunlight. So when the sunlight forms on this AgCl, the silver and chlorine atoms are separated. So silver remains in the solid form, but chlorine gas is liberated. So this is an example for photolysis or photochemical decomposition. Next, we move to the next question. What is displacement reaction? Explain its types with example for each. So it is another type of reaction called as the displacement reaction. When a more reactive element displaces a less reactive element from its compound, it is called displacement reactions. See here what happens. One element will be highly reactive, like sodium is there. Sodium is considered as a highly reactive element, and some other slowly reactive elements are there. And here a more reactive element displaces the less reactive element in the reaction. So that is called as the what is that? A displacement reaction. And here two types of displacement reactions are there. One is called as the single displacement reaction. In a single displacement reaction, an element reacts with a compound and takes the place of another element in that compound. So replacement of one compound is taken by the other. Okay, so here is the example you can see. So here single displacement is there. That means you can see here zinc is there. This is a chemical reaction. Look at this chemical reaction carefully. You can see zinc metal is there. It is reacting with this copper sulfate solution. It is a solution, aqueous solution. but it is in the solid form. And this leads to, the reaction of these two leads to zinc sulfate. Zinc sulfate plus copper solid is formed. So here you see zinc, because of its highly reactiveness, it replaces copper. It replaces copper, which is a slow reacting element. So to make the zinc sulfate and copper is separately formed. So here single displacement is there. That's what is called as a single displacement reaction. Next is the double displacement reaction. That means the reaction in which two different ions or group of atoms in the reactant molecules are displaced by each other is called double displacement reaction. It is also called precipitation reaction, as precipitation is generally formed in such a reaction. So this is the double displacement reaction. Sodium sulfate is there in aqueous solution form. Na2SO4 means it is a sodium sulfate compound. Another compound, reactive compound is there. It is the BaCl2, means barium chloride is there. It is another reactant. This is one reactant, and both are in aqueous form, solution form. So when you mix these two together, a product is formed. Barium sulfide product is formed, plus 2 NaCl, sodium chloride is formed. See here what happens, this barium, here in the Na2, actually Na2 replaces barium. So it becomes, what happens is, they are changing their position. Instead of sodium sulfate, barium sulfate is formed. And this sodium, when it separates from the sulfate, it combines with chlorine to make a sodium chloride. So in this way, double displacement is there in this chemical reaction, and two different products are formed, and hence this is called as the double displacement reaction. Next question, we will move to the next question. What are oxidation and reduction reactions? Give an example for each. So this is the question. Next question. What are oxidation and reduction reactions? Give an example for each. So first we'll see what is the oxidation reaction. Oxidation reaction means it is a process in which oxygen is added to a substance, or it is a process in which hydrogen is removed from a substance, or it is a process in which a substance loses electrons. So anyway, in three ways we can define this one. So it is a process in which oxygen is added to a substance, or it is a process in which hydrogen is removed from the substance, or it is a process in which a substance loses the electron. Here is an example is there. 2 copper is there, 2 atoms of coppers. It combines with the oxygen, leads to copper oxide in this way. So it is a process in which oxygen is added. It is a process where this oxygen is added to the copper, so to make the copper oxide, and hence it is called as the oxidation process. Next we will see what is the reduction process. Reduction process, it is a process in which oxygen is removed from a substance, or it is a process in which hydrogen is added to a substance, or it is a process in which substance gain electron. That means opposite nature of the oxidation. Oxidation reaction is opposite to this reduction reaction. The nature is completely different. You can see here, this sodium is there, it mix up with hydrogen, to form the uh, sodium hydride. So here you can see this oxygen is there. This oxygen is added to the sodium to make sodium hydride. But here, in this example, oxygen was added, but here hydrogen is added. So that is the difference, and hence this is a reduction type of reaction, whereas this is a oxidation type of reaction. Next, we'll see what is the redox reaction. Give an example. The reactions in which oxidation and reduction takes place simultaneously are called redox reactions. That means you can see here reduction reaction. It loses the electron here. So this oxidation and reduction reaction, both reactions are there. So that is why this is called as the reduction reaction. Because to this hydrogen, what is that? Oxygen is added. So and hence this is oxidation reaction. So this is the reduction reaction. That means here oxygen is removed. Oxygen is removed, and hence it is called as the reduction reaction. So both type of reactions, when they takes place simultaneously, it's called as the redox reaction. Next, what are exothermic and endothermic reactions? Give an example for each. First, we'll see what is the exothermic reaction. The reactions in which heat is released along with the formation of products are called exothermic reactions. So we can see here methane is there, CH4 gaseous form methane is there. It combines with oxygen, both are in gases, it is water oxygen. And these two together form the CO2, carbon dioxide is there. And plus H2O, water is formed, and plus heat is liberated. So in this chemical reaction, heat is released during the formation of a product, and hence it is called as the exothermic. Exo means out, release or out. Thermic means heat. So it is an exothermic reaction. Next, endothermic reaction. Next is the endothermic reaction. So the reactions in which the absorption of heat bar energy takes place are called endothermic reaction. So here heat is absorbed instead of released. So you can see here NH4Cl is there. It is the ammonium chloride in the solid form. Plus heat is absorbed in this equation, in this chemical reaction to make a product NH3, which is ammonia, and hydrochloric acid HCl is also formed. So this is an example for endothermic reaction where absorption of heat energy takes place. So to this extent, we have seen what is the meaning of a chemical reaction and what is a balanced chemical reaction, and what is the meaning of the word reaction, and what are the types of chemical reactions we have seen with their example. And in the next session, I am going to start the new things of the same chapter. I will start from this. What is that? What is corrosion? Okay, some other portion of this chapter we will cover in the next session. Thanks for listening.